Okay, today's lesson covers Unit 1, Lesson 1, which is literal equations. And I am a firm believer in knowing what these words mean, so I'm going to refresh your memory if you do not know. But literal equations are those equations that have more than one variable in them. Okay? Now, I've updated this lesson from how I did it last year, but it can still, more importantly, the important why I'm telling you that is because I'm going to go start at at problem group number 3. This is group number 1, and I added some problems to it, and so I'm going to start with group number 3 because I think those are the easiest, and then it kind of warms up. But to do that, I also want to refresh your memory on the order of operations that you should know before coming into this class. We have an order of operations so that we make sure we all get the same answer when we work a problem, no matter whether we're in the US or France or Japan. So you all are familiar with the mnemonic device of PEMDAS, P-E, and when I first started this, I used to write it all vertically, and then I changed because I felt like it helped people understand and remember something about it, and I'll explain that in a second. So the P, you remember, stands for parentheses. The E stands for exponents. The M stands, excuse me, the M stands for multiplication. The D is for division. A is addition, and S is subtraction. So why do I write them left and right here in order instead of vertically? Because when I used to write them vertically, people thought that you did all multiplication before all division, and that's not true. So when you have all multiplication and division, you have to work in order that you see it in the expression from left to right. And the same thing when it comes down to addition and subtraction. You don't do all of addition before you do subtraction. Okay? And the other thing that I want to review with you is the difference between solve and simplify. Okay? In case you don't remember. Okay? To solve something, that doesn't quite look like an S to me. So I'm going to fix that. To solve, you can solve, most of y'all know, to solve means to isolate that variable. Get that variable all by itself. So the thing that you want to remember is that we solve equations and we simplify expressions. Okay? What's the difference between these? An equation is two expressions that have been set equal to each other. So if you don't have a, oh, go away. Sorry. An expression has no equal sign, an equation does. And why do I want to talk about that is because solving of equations, you generally will go in, oops, lost my pen, excuse me. Okay, you generally will go in the reverse order of your operations. Okay, that's kind of a safe way to think about it, but of course some of them are different and the rules can change, but that's a general rule of thumb to think of. If there's addition and subtraction and that's the last operation, then that's what you want to do first. So let's go look at our examples here. I'm going to start with A, which says P equals 2L plus 2W, and we're supposed to solve it for L. So we're trying to get this guy all by itself. And you might recognize that. That's the formula for the perimeter of a rectangle. Perimeter equals 2 times the length plus 2W. So if I'm going to solve for L, I have addition and subtraction, and that means I got to get rid of this 2W because I'm trying to get the L all by itself. So I'm going to subtract 2W from both sides of my equation, and that's going to give me P minus 2W equals 2L. And generally we write L's, we write cursive L's, so it doesn't look like a 1. And then we're going to isolate that that L further by getting rid of that 2, and we get rid of that by dividing. Now, that cancels. And an equation can always be flipped. That's our symmetric property, excuse me. So L equals P minus 2W over 2. Now, I want to point out, because some people had questions about this, when you're at this step that says P minus 2W equals 2L, you could, when you divide, you can write divided by 2, and then divided by 2, and then divided by 2. Okay, so here I did it over the whole side of the equation. Otherwise, you can do it in each term. And when you do that, these 2's cancel, and these 2 cancels, but notice there's no 2 there that cancels. So the other way to write this would be to say L equals P over 2 minus W. Okay, you cannot cancel it out here because 2 is not a factor of the whole numerator. It is only a factor of one part, or what we call a term. These two expressions are the same. They're equivalent to each other, but I'm telling you, you can leave it like this. So unless you are absolutely sure that you know how to do it correctly, leave it like that. Okay? If you want some help in it, I'll be happy to do so. Okay, so that's A. Let's go look at B. Okay, so this one looks a little different because it has parentheses in it. Keep in mind, as you know, there is more than one way to solve a math problem. So I love math so much. But no matter which way you solve it, if you do it correctly, we will all get the same answer. So you can, your inclination might be to distribute this 1/2, but you can also get rid of it because I'm trying to get rid of anything on the side of R2. So to get rid of that 1/2, I can multiply both sides by 2. And so that's going to give me 2R is equal to, and 2 times 1/2 on this side goes away, leaving me with R1 plus R2. And then if I am solving for R2, I need to get rid of R1. So I'm going to subtract those. And that leaves me with R2 equal to 2R minus R sub 1. Okay, and one of the things that I did point out in class is that the absolute minimum that you should show me when you're doing these problems is this line right here in between. If you go from the problem to the answer without showing me something in between, you won't get full credit for the problem. I'm really big, so get used to it all year long, that you got to have work to support your answer. Anything else that I wrote is extra, and you can choose to write it or not to write it. Okay, going back to, it went too far. I just wanted to go there. Okay, to number 2. When you look at that, I asked class, and they're like, oh my goodness, it's a word problem. Well, they thought it was a word problem, but really, if you look at just this part of it, that's exactly what we just did in number 3. All these other words are just telling you what the formula means, where C is the temperature in degrees Celsius, and F is the temperature in degrees Fahrenheit. It's like, the first one would be like this if I put where P is the perimeter and L is the length of one side and W is the width of the other side. So that's all that's different about this. But we're going to go ahead and do this example just to get you going. So again, I have a 5/9 over there that I'm going to get rid of by multiple. Oopsie, that's not what I want to do. I got to go back to my pen, then choose that color. Okay, so let's try that again. There we go. So I'm going to multiply both sides by 9/5, and that gives me 9/5 C is equal to F minus 32 degrees. Again, I'm solving for F, so I got to get rid of 32, and I'm going to add that to both sides. And putting this line in there, y'all, makes it easy to tell that you're adding something to both sides of the equation. But you could just write this line here, and then know that the 32 is going to go to the other side, so my answer is going to be 9/5 C plus 32 degrees. Okay, on to the first one. Because these are a little more challenging because we have to solve for something, but we don't even have an equation there. So we got to come up with an equation, and that's why I had you do the formulas the night before, so you would all have these formulas handy. But first off, look at these directions, and it says write the answer in, what color did I choose? In the right color. Okay, good. Write your answer in function notation. And you think you don't know what it means, but when I write f of x, you all go, oh yeah, I know what that means. We've seen that before. Well, that's function notation. And you've also talked about a dependent and an independent variable. Okay, so to relate it back to something that you know, if you remember doing t-charts, this was x and this was y. Well, one of those was independent and one of those was dependent. So if you don't remember, I will tell you that the independent one is x and the dependent one is y. Okay, so one of the things, some people remember it lots of different ways, so I'm going to give you some ideas to help you remember, because you have to be able to tell me which one's independent and dependent. Some people remember that this is independent because I chose that number. You choose these numbers and you plug it in, and whatever you chose here, this answer depends on that one. Now, in function notation, when you see it like this, I will tell you that the independent variable is always inside the parentheses. So when we have this function notation here, okay, which is what we're going to write here, a of c, inside is the independent, and that leaves outside to be the dependent. Okay, now something else I want to point out here. This says, what is an equation for the area of a circle as a function of its circumference? So notice that it went in order: area as a function of circumference, area as a function of circumference. So the way it's written in the sentence basically tells you exactly how to put it in your function notation. Okay, so let's go do this. And the first part of it, where are we going to start? Well, we have an area of a circle. We know area equals pi r squared. And we have the circumference of a circle. Circumference equals 2 pi r. Now, this area, we don't write it in function notation, but if I did, what is it a function of? It is a function of r, because r is the variable on the other side. But we have to write it as a function of c. So a of c is equal to what? And that means that I have to go replace that r. I can't leave r in there. I got to figure out how to write r in terms of c. So I'm going to have a pi, and then I'm going to put something in there and square it, but I got to figure out what that is. So that takes me to that second equation, and to solve for r, you all know, divide by 2 pi. So my 2 pi's cancel, and that, so this usually, anyway, r is equal to c over 2 pi. Okay, so when I've solved for something like that, I like to circle it, because this is what I'm going to go plug in right here. Okay, so instead of writing r, go back to my blue, I'm going to write c over 2 pi. So I have written the area as a function of the circumference, because the only variable over here is circumference. Now we have to simplify that. So just to help you, because we haven't had that much time to review, I have, because it's a fraction, let's talk about this. We got pi, and then I have a squared, and a squared means that that term is a factor twice. So I'm going to write it like that. And because I have fractions, I always like to make everything a fraction, and then it makes it easy for me to see what's on top and what's on bottom. I have a pi on top and a pi on bottom that cancels. There is nothing else that cancels, so that means on top I'm going to have c squared, and on bottom I'm going to have 2 times 2, which is 4 pi. And so that's our answer. Okay, let's go with B, and this is the last problem. So, all right. What is the equation for the area of an equilateral triangle as a function of, so I know I'm going to have area as a function of something, the length of one of its sides. Okay? Now you might choose L, but we're actually going to choose S because I know that it's equilateral, and that's the letter that we use when we know that a figure has all sides that are equal. Okay, which means inside is the independent variable, so this is S, and the dependent is A. Okay, so then we went back to, all right, I'm going to write that formula. Area of a triangle. Area of a triangle is 1/2 base times height. And I don't have another formula. See, up here they gave me area and circumference, but I don't have another one. So then we got to think about going and drawing a picture and seeing what we can get from a picture. It's equilateral, so I know that all the sides are S. And if all the sides are S and all the sides are equal, then all the angles are equal. So all those that add up to 180, so 180 divided by 3, of course, is 60. So when I plug this in and I'm writing the area as a function of the side, then I have to figure out the base of my triangle in terms of S and the height of my triangle in terms of S. Well, people are having trouble saying, okay, that base is S. What's the height? Well, remember, we find the height by drawing a perpendicular from one vertex to the opposite side. So when we do that, this, well, before I go there, let's talk about, move this so you can see it. The whole side was S. Okay, when I drop that perpendicular down, remember from geometry that that 60 gets divided in half. So each side, each of those angles is 30. And I now have a 30, 60, 90 triangle, which you talked a lot about, hopefully, in geometry. So this is the short side, but you already know if I drop this down and these two are the same, that's your isosceles triangle theorem. So this becomes 1/2 S. Okay, so the short side is this. The hypotenuse is twice that, and twice that is S. And the long side is the short side times the square root of 3. So that means this right here, poo. I don't like that color. This. Okay, that is going to be the, okay, height of my triangle. So I'm going to go put in 1/2 S times the square root of 3. And some people needed some help simplifying it. So what I do when I see that expression, okay, what's on top? This S is like over 1, and this is over 1. So on top, I have a 1 times an S times a 1 times an S squared root of 3. And on the bottom, I have a 2 and a 1 and a 2 and a 1. So obviously we don't need to worry about the ones, but nothing cancels. I'm just trying to show you how you can easily see nothing cancels. And that gives me S squared, square root of 3 over 2 times 2, which is 4. So that's our lesson for Unit 1, Lesson 1. If you have any questions, please email me or come see me.